welcome back. So what we're looking at today is 2.7, the x factor. So let's go ahead and get started. All right, so exploring the density of the number line, find three numbers that are between the two given numbers. So the first one we're going to look at, well, the one that we're going to look at here is 5 3/4 and 6 1/3. So we need to find numbers that are in between those. Well, 5 3/4 is the same thing as 5.75, since I'm guessing most of you are panicking because of all the fractions all over this. So we have 5.75. 6 1/3 is 6.3 repeating. So we just need to find decimals that are in between there. So one would be 5.8. 6 is obviously right in between here. And we could do 6.2. Those are three possibilities. Now, those are not the only possibilities for answers there. There are so many possibilities because you could do 5.76, 5.77, 5.78. Those would all be in between 5 3/4 and 6 1/3. On the ones where you have the square roots, take the square root of the number, then find the decimals in between those two. Okay? That'll make this nice and easy. So this is all about just finding numbers in between any two given numbers. And there's an infinite number of possibilities for what you could put here. Because honestly, you could put 5.751, 5.7501. Those are possibilities, just extending out to a further place value on our decimal. So, and we can go infinitely far on those decimals, okay? All right, the next part of this is factoring quadratics. The area of a rectangle is given in the form of a trinomial expression. Find the equivalent expression that shows the lengths of the two sides of the rectangle. So what this means is we're factoring. Just like we did before, we are factoring these. So I'm going to do a few of these with you just to kind of make sure that you're getting the hang of it and have a lot of examples. So we're going to look at this top row. All of the C values, notice, are 8. So we have 8. We're looking for factors of 8. So we have 1 and 8, 2 and 4. That's it. So those are our factors of 8. So when we come over here, we have x squared plus 9x plus 8. 1 plus 8 equals 9. 2 plus 4 equals 6. So we're going to have x plus 1 and x plus, oops, I forgot my plus sign. Sorry. Plus 8. Now it's factored. Now on number 10, be careful with this. The C value is positive, but our B value is negative. Now, in both of our cases over here, we multiplied with positive values to get a positive 8. But if we change both of these to negative, so -2 and -4, negative times negative is still going to give us a positive 8, but -2 plus -4 is -6. So x minus 2, x minus 4. Now, the ones that are a little more difficult, when our C value is negative. So I'm going to come over here, -8. Now, same thing. We've got -1. Whoops, that's supposed to be a -1. -1, positive 8. We've got -8 and positive 1. We have -2, positive 4, and -4, positive 2. And yes, it does matter that we switched which one is negative. So this first one here is going to give us a positive 7. This one is going to give us a -7. The next one, -2 and positive 4, that's going to give us a positive 2. The next one is going to give us a -2. So based on our problem, which B value do we need? -2. So we want x minus 4 and x plus 2. So you guys have to be very, very careful on this when we're taking and determining which one needs to be negative, which one needs to be positive. If your middle number, your B term, is negative, that means the larger of these two numbers, notice the 4 is larger than 2, it's the one that's negative. That will always be the case if your B term is negative. The larger of the two numbers has to be negative then, okay? All right, the next one I'm going to look at with you guys is number 21. So we have x squared minus 25. That's it. We have no B term. So this is what's called a difference of two squares. X squared is a perfect square. X times x gives us x squared. 25 is also a perfect square. 5 times 5 gives us 25. And we have the subtraction sign in the middle, so difference of two squares. So the way we factor these, and this will always be the case, we take the square root of both values. So the square root of x squared is just x, minus the square root of 25 is 5. Then we do it again, but with positive value. So one of them will be negative, one of them will be positive, because that's going to cancel out your middle term. Because our middle term, if we did FOIL on this, would give us negative 5x plus 5x. They're going to cancel each other out. So that's how we factor a difference of two squares. So that's just a formula, a rule. You just take the square root of each value. You do one with a plus, one with a minus. It'll work that way every single time. And you can always multiply it back. Do FOIL and see, does it actually give me what I need? To double check that you did it right. Okay? All right. So all of these are equivalent. So saying x minus 5 times x plus 5, that's the same as having the x squared minus 25. It's another form of the equation. They are equivalent. So equivalent is your key word for this lesson. Equivalent. All right, what we're looking at next is graphing parabolas. So graph each parabola, include the vertex and at least 3 accurate points on each side of the axis of symmetry, then describe the transformation in words. So I'm going to take and draw the parent function for you and then kind of explain how the different transformations work, but not do any of them because I want to see you do the transformations. So for our parent function, it's just f of x equals x squared. So anytime there's no transformations on a graph, that is what's known as the parent function. So for a linear function, it'd just be the equation y equals x or f of x equals x. That's the parent function. There's no change to it. All the changes we make by having a slope other than 1 or having a y-intercept, those are all transformations. So for this, if we plug a 0 into this, 0 squared is 0. So our first point and our vertex is at the origin. Now, 1 squared is 1. So there's our next point. And it's the same on the other side because we have symmetry. 2 squared. 2 squared is 4. So we go up, 2, 3, 4. Once again, we have symmetry. So we go to the other side. Negative 2 is also going to be 4. Now we go 3. 3 squared is 9. So 4, 5, 6, 7, 8, 9. Then we go over to negative 3 and 9. So this is our parabola. This is what the parent function of a quadratic equation looks like. Sorry, my line isn't better, or my curve isn't better on that, but that is our parent function. So this is parent function. That means no transformations. No transformations have occurred on this. Now, when we add or subtract a number to the outside of this, so like in number 30, when we're adding or subtracting to the outside, that means it's either going to move it all up or all down, depending on whether you're subtracting or adding. When we have a number inside the squared, so like on 31 and 32, when there's a number inside, it's the opposite direction it should be, or that you would think it would be. So if it's minus some number, that means you're going to the right that much. If it's plus some number, you're going to the left. So it's the opposite direction, you would think. And then if there's ever a negative on the outside of your parentheses, that means instead of going upwards, it's going to go down. It's going to be a upside down parabola. So it's going to look more like an N than a U. Okay? So that's just a little bit about those different transformations that you're going to see. I want to see how you guys do with graphing those out and describing their transformations. So remember, your keyword is equivalent. If you have any questions, feel free to ask. Have a great day, you guys.